Well, hi, thanks again for joining me here in my shop. So I didn't work in here yesterday. Yesterday was cable day. The cable guy was here yesterday, wandering around my house changing a few cables for my cable TV. So that was the focus of yesterday. Today, okay, time to do something more with this radio. Now I've been reading over the service manual. It's a really great service manual, no doubt about it. Certainly envisions a top level service shop to facilitate the testing that's recommended in the service manual. And the equipment I've got here is pretty close. In fact, maybe with a little more experience, maybe I could even perform all those tests. But I think the situation, frankly, for me, is if I go ahead and attempt to perform these fairly demanding tests, feeding in certain levels of signals into certain circuit points, measuring the output either at the speaker or AVC or other places too, I'm pretty sure if I attempt to do those tests, which are designed to kind of check through the radio at different stages and just make sure everything's working okay. If I attempt to do those, I think in most cases where I'm looking for a result, let's say of 10, and my test yields a result of 8, I will just stand there and scratch my head, not knowing if it's saying something about the radio, something about the test equipment, something about problems like even the leads and things like this, and problems even inside my head. Yes, there's problems in my head on this stuff too. So I'm pretty sure the end result after all that effort would be me saying, well, I really don't know anything more than I know already, because the radio appears to be working. So it seems to be working kind of okay, although we don't know about the transmitter side of it. The receiver side appears to be working. So with that in mind, I'm just going to reject the idea of going through all the circuits via the service manual for the reasons I've explained. And instead I'm going to be very selective, and I'm going to jump right to the issue of whether the IF circuits are tuned properly. The IF frequency, the intermediate stage frequency in this radio, is 455, like so many radios. And if that's a little off, then because this radio is crystal controlled, when I snap it to a particular crystal controlled channel, in fact the receiver will not be receiving the frequency it's intended to receive. It'll be a little off, and it'd be very hard to realize it just playing the radio, because you'd just be thinking there's nobody transmitting when in fact there could be something out there. Really? You think there's something out there, Jim? You know, only under skip conditions can I be fairly certain there's somebody out there transmitting for me to receive here. On a normal everyday day here in Aurelia, I'm going to take a wild guess that there's virtually nobody talking on CB radios. Now I'll take that back. There is a fairly major highway, goes right past the town. There could be truck drivers up there talking away, so I'm not even sure this thing can tune in the truckers channel. So taking all this stuff into account, then what I'm going to attempt to do is a fairly straightforward check the IF to make sure it's tuned to 455. That's something I've certainly done a million times here. I can do it again. But by the way, look, I've got a plethora of CB antenna. These are for crying out loud, SWR meters. Typically, CB people were really interested in SWR, standing wave ratio, on their antenna lines, and so I've got 2 meters. I got 2 meters and an antenna. Hey, good show. I just don't know if I really have a transmitter here yet, but we're a little ways from finding that out. So in thinking about how am I going to check to make sure this thing is even receiving on the right channel, and even what channels it's receiving for sure, how am I going to check that? So I think the way I'm going to do it is I'm going to grab this other CB radio here. Let me take it over here. Put it like that. Now this radio is hooked up to an antenna that's in the next room, but this is a fairly strong radio. it would be a strong walkie-talkie. So this is going to put out quite a powerful signal. You can read the channel number here. It's channel 9 right now. Let's get off that channel right away. Let's put on 10. Maybe we'll hear some truck drivers here. And we'll check the volume and the squelch setting here. Okay, so we're just barely squelching out the signal. Breaker 1.0. Breaker big channel 10. Yeah. So I can select the channel here, transmit with this, assuming this is on target. It probably is. This is probably also crystal controlled in some way. Probably the channels are perfectly accurate. That's what I'm going to assume. So we should be able to figure out what channels are being received over here by transmitting on them over here. The distances involved here is kind of tight. What I can do is I can reduce the amount of antenna on the receiver to make sure we're not overloading it. But I think there's quite a range of AVC voltage in here. It goes all the way up to 30 volts. So maybe this thing is pretty insensitive to powerful signals hitting it. We're going to find all this stuff out. So number one, what crystals are in here for sure. Yeah, I'd use my signal generator, but I think again it will just leave me just a little uncertain. I think I like the idea that it's got the number right there. Okay, so I'm going to power this guy up. AVC meter is hooked up just out of view right here. Let me move that camera a bit. Okay, power on here. You can see the dim lights come on. Currently, this is connected, I believe, to the signal generator, which is actually operating, but I can just flip this button here. Now it's on the antenna. Doesn't seem as seems like I gotta turn the volume up a long ways here. Doesn't sound right. It's because I have no antenna whatsoever on it right now. That's why. I took this off earlier. One of the tests, very basic tests, is to read the resistance from the antenna back towards the radio. I was supposed to read, I think it was 47,000 ohms, I think, and it read 46.5. So that's why the antenna's out. That's why it sounds the way it sounds. Let's just reassure me that that's all it is. Yeah, that's a lot better. Okay, I'm going to take the antenna off again to reduce the amount of input here. This is set to channel, oh, one of these channels was 14. Okay, so we're on the first channel. We don't know what it is. How am I going to do this exactly? The other thing too is that this may be received over a range of channels because of the distances here. Let's go. They say this reacted already. It's not reacting now. Channel 1. So there's no crystal in 2 and 3, that's right. I remember right, 14, channel 4 was 14. Let's just turn the squelch up a bit here. Well, 14 seemed to be the one that's interesting. That how many channels you could hear this. Wow. Okay, that's for sure. That's for sure 14. The question is really what this last one is. And it could be 22. The reason I say that is because the manual talks about 22 being important here. $15. This is a poor way of doing this, as it turns out. 16. Well, it looks like 1, 14, and 16, but boy, I don't have a good feeling that I figured that out at all. Okay, let's do it another way. We'll compare. Channel 1. Should be up 27 something. $27,007. I believe all the channels they end in like a 5 here. Let me just pop it up on my own screen and take a peek. And we'll see now. So if we're getting 2705, that would be channel 4. Or is it 2715? So normally you add 1 or 2 to this number to get the exact frequency. You see the problem? The problem is if you add 1 or 2 here, you get 2710. And there's no such channel. It's 27005 or 27015. 10 is in the middle. So this is beginning to hint that the radio is not receiving properly. How accurately did I get it tuned? So we can check the tune accuracy by keeping an eye on the ABC voltage here. I'm going to be just let me tune the there. Now we'll get maximum ABC voltage here. That's about it there. So what I've ended up with is 27. Pretty much the same thing. 008, 009. So I'm going to grab another radio, a digital radio. I'm going to tune in the signal generator and verify the transmitting voltage, transmitting frequency. So hang on a moment. Okay, we got another radio here. Tune it up to 2700. This is the antenna here. Pretty interesting. $27.17. Very close to 27015. 2715 would be channel, let's see, 2715. Just check the chart here. 2715 would be channel 5. Channel 5. Really? Channel 5? Okay, so let's see what happens here. Take this off again. Channel 5. Well, now this is receiving the signal generator. That's pretty interesting. Okay, so this has got to be the right one. Yeah, I didn't have to actually transmit, did I? What I can do now, this has a signal strength indicator. Receive. These lights, anyway. Hard to see in the camera, aren't they? But the first one and the second one are on. So, 5. I'm going to vary the signal generator here. Try to watch the signal strength on the little walkie-talkie at the same time. And listen to it. I would put that. I would say that is exactly on channel here. Channel 5. It's really 27015. My signal generator is tuned properly. Assuming, of course, we're using this as the standard now. Could bring the other one down. I have another one of these we could compare. You know what? That's a good idea. I'm going to grab the other radio, bring it in here, and we'll compare. I'll go get it. I got room for another radio, don't I? Okay, so this should be a pretty easy matter of just swapping it out here. This radio is normally on down at the other end of my house, in my office, studio, shack, whatever you want to call it. Ooh, that didn't come out too good. Okay. It's on all the time, monitoring, I think 26, I can't remember now, 26, 28, something like that, channel 26 or 28, where supposedly most people go to do the skip thing. So this is my skip monitor. It's just on with the squelch up, waiting for skip to show up. Okay, and we wanted to check, we want to put this on channel 5. Now we want to try turning the frequency over here and see if this one shows anything different. Actually, we kind of want to transmit with this, don't we? Who knows? Just stop thinking, do something here, Jim. Right, maximize the signal here. I'm getting lost in my own stuff. There we go. This is 2706 to start. say that's it. Got a new number. 2703. 2703. So what we're saying is when this radio is tuned to channel 5, I seem to get a max at 2703. The other radio, 2710 or something like that, wasn't it? A little hard to be absolutely within a few cycles there. I just can't be that accurate. This is a repair I did where the built-in phono plug broke off the board inside typically, so I just extended the wire out. In case you're wondering what's going on there, that's what that is. Okay, channel 5. One light. One light there, not two. Right in there. Hey, it's almost the same. Okay, once again, I imagine these are using circuits which maybe literally cannot go out of tune. So I think we can rely on these. I have to. I don't have too much else. Do I have anything else? I have only that other channel 14 handheld walkie-talkie, which I would not rely on that at all. So this will be the standard. And I guess, in a sense, within my house, it makes some sense to make sure all these CB radios are kind of working on the same channels and that. When the cable guy was here yesterday with his fancy instruments and that, I pulled this out. This is my cable measuring meter. I pulled this out and we tried calibrating this. Didn't. You know, this is really intended for back in the days when the cable TV signal was just a radio signal coming to your television, and that's what this is trying to measure. Well, today there's so much more on your cable. I really don't know what this thing is doing, if it's doing anything useful. But nevertheless, I talked the guy into trying to calibrate it with me against his instrument. So I had lots of fun with this cable guy. I think his eyes kind of popped out of his head when he came into this house. Yeah. Okay, set this one over here. So now we think we got this thing right on channel 5. So now, with knowing this is on channel 5, exactly, let's turn this down here. If I vary the frequency here and the reception on the radio I'm working on improves, then I'll know that this is not really tuned properly. And this is a bit of a tricky thing. I've got the AVC voltage on this meter here, so we should watch this meter. See if we can get it on screen here. There we are. So this meter will show AVC. It should actually be, if the radio is tuned properly, this should be up at its peak right now. So the first channel on here is channel 5. I'm just thinking to myself, channel 5? Really? That's what they put in here? I can pop the crystals out and read the actual frequency right on the crystals. I think we're going to end up there before too long, because this isn't giving me a good feeling here. Okay, let's try the variation test. So you gotta watch that meter there. This is all about that meter. There we go. So note where it is. Let me in fact do this. Okay, 5-volt scale. We're around 1.5 volts. Will it go up? That's the question. Okay, here we go. Down that way. And the other way? Down. So what this is telling me is that this radio is perfectly tuned. That it is definitely on channel 5. So there's a fair bit of crystal controlling here, certainly on the transmit side. Is it crystal control affecting the reception exactly? I don't know. I have to study the schematics some more. So next thing to do, I think, is to actually read the crystals on this. I think that would be another way we can be sure of things. And it may even say right on them, channel this, channel that. See if I can read them without pulling them out, first of all. Johnson. Yeah, it's going to say up on the top probably. Yeah, I can start reading the frequency there. Okay, that's great. So what we'll do is I'm just going to take a couple screws out of down there, and we'll pop this shield off the top, and we'll be able to read the frequencies directly. And I really don't expect any kind of problem here. Okay, just a flat. Flat. That screw looked loose. Is that my imagination? Yeah, that screw is loose. And the other one's pretty loose too. Won't this just come right out now? I have to remove the screws. Screwdriver here. There's some holes in the cabinet that if I pull the screw out and drop it, it can go right down the hole. And who knows where from there. And the screwdriver's not going to grab it. Yep, there we go. Undid it. Let's try it again. So much for that. Screwdrivers are better for putting in screws than taking out screws. Okay, just don't drop it. In fact, let's grab this. I guess one way you make money with one of these things is to build it for 5 channels and sell it with 4 crystals missing. So you sell it, the guy who buys it right away wants to buy 2 more crystals from you. Okay, let's put all this together here. Okay, well, let us look and see now what channels we got installed in this. This is channel 13. 13 transmit, 13 receive, 15 transmit, 15 receive. Receive on 5, so it is 5. Okay, so we got 5, 015. 26. Now that's interesting. Why are these two different frequencies? So the receive frequency here, 26,560, is probably the IF away from the intended reception frequency. So I bet you subtract 455 from that. Calculating now, and you get 455. 5. Doesn't quite work, does it? Take 455 from 560, you get 105. Not 015, 105. Am I doing this right? Oh, you add it, because this is 26. You're really aiming for 27. Right, add it. Now add 455 onto there, and presto, you get 015. So there we are. So that's just a chip with the IF frequency. Hey, Johnson. COB, cash on the barrel. Frequency written there. Very good. So the channels are, just to get it in my head firmly, 5, 13, 13, I thought it was 14, and 15. 13 and 15, either side of 14. 14 being the typical kids walkie-talkie channel. Isn't that interesting? I wonder why they did that. 13, yeah, that's what it is. 5, enough. 5, 13, 15. 5, 13, and 15. The alignment instructions say you need to get to channel 22 to do some of it, if you were to follow the service manual precisely. So what are we finding out so far? We're finding out everything seems to be really pretty good with this receiver and that. Could check the other channels. I'm not sure why. If one channel shows up properly, you know what we can do? I know what we can do here. I'll finish what I'm saying. If you can measure one channel, you know you're putting in the correct frequency, and it's being received, and the channel is crystal controlled, then you know the IF must be on the target. If the IF was off, proper frequency wouldn't mix with the crystal properly to come out of the speaker. So that kind of proves the 455 is correct. But we'll try that another way. We'll just feed 455 into this thing and see what comes out of the speaker. You know, we'll just jam it right into the antenna, as inappropriate as that might be in some cases. I think we're okay here. Okay, so this radio's on. Don't forget that. .55 on the signal generator. .55. Fairly low signal. Higher. Higher. Okay. think I have the radio set to the antenna, not to the signal generator. Let's knock it back. Signal generator now feeding right into the antenna. .455. I really expect to hear it here. A very, very strong signal now. Wow, what's going on? Never going to hear it. Oh, there's a speaker. Up, up, up. Okay, something not quite right here. Shouldn't really hear a hum like this. Why is that? What's up here? Something funny going on. Where'd that whopper hum come from? Oh, okay, hold on. Power off here. Like an idiot, I flipped this down with a clip lead under it there. Duh. And this is probably... So this is the AVC. Check voltage there. That's probably what was causing the hum. Probably. Power back on. Okay. What silly thing have I done here? Oh, I bet you the ground, yeah, the ground came off my meter. So that turned the whole meter basically into an antenna. Yeah. That's what it was. Okay. Let's put this back on. I can remember where it's supposed to go. Right in here. Okay. Yeah, so I guess when I put the radio down, I knocked this ground lead off. That's what I did. Everybody's back to normal again. Now we can go back to trying to find the 455. Okay, so volume up a bit. Power's maximum on this. Let's knock it back. I kind of really expect to hear something here. Okay, that's all she's got. Well, okay, so injecting through the antenna is not working. There could very well be a little circuit in there to filter out this exact frequency I'm trying to pump into the radio, so it can't make it there. And here's another possibility too, and that is I don't have the signal generator connected. Yeah, that's the real problem. That's the real problem. Let's try it once more. One more time. Channel 5. Doesn't really matter. 455. Let's try it here. Come on. There it is, finally. Sorry about the focus going a little wild there. so by my reckoning, it's right on 455, but this should really say 453 at this point. I think I want to get this really, really precise. Maybe try another signal generator. 455 on another signal generator. Okay, let's do that. The last few times I've used this signal generator, I've got a little bit of a antsy feeling about how accurate this is. I've always believed it to be 2 digits high. I want to get this precise, so we'll take this, pull it off there, and we're going to put this. I need a little bit of a longer lead here. Who's got one? So we'll set this guy up to 455. Or nearly so. .430. So we're at 430 here. A very low level signal coming towards the radio. Let's give it some more oomph here. And we'll tune past the 455 mark. Didn't hear a thing. Crazy thing was sweeping. I don't want that. Okay, now we got problems. Got this set wrong because it was on sweep. 455. There it goes right past it. So and we'll bring it up, get a maximum on the meter over here. It's a little hard for me to reach across. Okay, so I'm watching that meter now. Right there, quite distinct. We're up to 456.1. So we got this one saying it's a wee bit high. We got this one also saying it's a wee bit high. I think we're a wee bit high. So what I'm going to do, I'm going to put this to 455, and then we're going to peak the IF in here at 455. .455.07. I don't think it's going to get more accurate than that. I think it's a pretty reliable signal generator here too. And frequency counter, most importantly, is quite accurate. So now I'm going to want to do the 2 IFs. Okay. What's up there? turning the whole connector here. Don't turn it so tight. I think there's a little bit of a problem right in here. Okay, I won't dwell on that. I have more to say about this, but I won't bother. Some previous things that went on. Oh boy, that's really not. I got 20,000 things in here in series. It's this. Okay. Wow. Well, I don't know what's going on there, but I think we just leave it alone. Leave it alone. We'll be okay. IF. I have to figure out I have to figure out a lot of stuff here. A lot of stuff to figure out. Okay. I think I'm all set here. I'm not sure the size of the slugs that are inside those cans. Got the ABC voltage here. Let me just change the scale a little bit. And the frequency generator, this one's drifting. My old military one doesn't drift at all. This one drifts. Put it back to 455. There we are. Now, let's start with this. Take what I think is the second IF down here. Okay, it doesn't want to go. Let's try a slightly smaller end. I think these are actually the same size. I can kind of feel the top, but it's too big. Okay, now let's try this one here. No, it's not going to go in. Okay, try this one. Smaller here. Boy, oh boy. Really? It's not going to go in there? Okay, so it really feels like a hex slug though. Just can't get a bite on it. So just before I clicked start on the video, I was holding this tool and it just broke right in my hand. This is the right size, I think. What am I going to do with this? Watch my fingers here. Okay, you know what? I don't think that's even going in. Or maybe it's slotted and I'm mistaken. Oh boy, how are we ever going to see in there? Huh. Okay, let's take a look. See if we can see see if we can see what is to be seen. Just need a glance, just a little glimpse in there. Just give me a little glimpse. A little further. Wow, don't short anything out here. I should probably. Getting anywhere there. Let's try looking in from the top here. Sometimes they can be closer. Oh, what is that? What the heck is that? Looks like a capacitor screw head. Let's look at another one. I really couldn't tell you what I'm seeing in there. Is that just a wire near the top of it? Just stick a screwdriver in there and see if it'll pick up on the So that's a flat edge on it. Let's try this one. You know, that what it looked like I could see in there is a huge wide, screwdriver thing, and when I put this little thin bladed screwdriver in there, it rotates back and forth almost 30 degrees before it bumps into the, more than that. What happens on the top? So I don't know what these are. Wrong one. Can I get in the top here? It's the same thing. It's like it's. It really feels like a huge wide slot. I've never seen anything quite like that. Huge wide slot. What have I got, a huge wide slot tool? This metal end that's pretty wide. And I have a plastic end. Slot. Okay, I think we're ready now. After all that. Okay, starting on what I think is the second IF, starting in the bottom. Okay, now, first of all, are we on frequency? No, it's drifted again. I have to keep that in mind, that this is a drifter. Watching the meter over here now. No, it's not really in focus. Up, down, up. A tiny amount of that. We're on our way. Okay, other end of the transformer. Right there. You probably didn't even see the meter move, but I could see it moving ever so slightly. Now we'll try the Other one. Okay, we're in. Watching the meter now. Look at this one. I got a fair bit out of that. Well, I don't, I actually don't. Can't really relate this to just how much better the radio might work. Here we go. Remember, this radio you can't tune to compensate for small errors because it's all channeled. You gotta get this thing right. Okay, so now we'll do the peak check. I'll vary the frequency, and we'll just watch this meter, and when it's at top, then we'll read what's on the digital meter here. I'm gonna stick my hand right in front of right in front. Who's got me? There we go. Too many wires in this shop, by the way. Everything gets caught on them. Okay, where is the peak? So we'll vary this, and we'll stop where the peak shows up. This is a little difficult to tune. You can hear it in the... Okay, so that's definitely that's the peak on that meter. And the frequency is 455.8. And if we put this back, hey, where'd the voltage go? Okay, stay put. Down, so this is at 4.8. Set this back so it says 455 exactly. So I couldn't hear any change in the radio, and this is 4.8 still. So, we're kind of within the error range of everything we're doing here. Perfectly acceptable situation now, I'd say. That's great. What's next for this guy? So what have we done? So we've verified the IF is on frequency now. We've noted what channels the crystals, what particular set of crystals the radio has. Oddly enough, it's channel 13 and 15, either side of 14. Maybe their thinking there is these handheld walkie-talkies are, they're not very accurate at all. The old cheap ones, toys, let's say. So maybe their thinking was a lot of stuff on channel 14, but a lot of stuff not quite on channel 14. So if we put in a 13 and a 15 crystal, surely to goodness you're going to pick up a channel 14, 13, or 15, not 14. That doesn't make 100% sense, does it? I'm just trying to figure out what's going through their heads there. This channel 9 is critical. There's no channel 9 in here. Channel 10, it became the trucker channel. Something about channel 11, I can't remember. Channel 6 was something, this is all kind of loosey-goosey. This guy's got 5. 13 and 15. Let's pop it on the antenna. Any skip coming in? I'd say no. Okay, I think that's where I'm at today. IF is checked out. IF is okay. We're on to some other stuff from here. I think that's all I'm going to get today. Thanks so much for watching, and onward we go.